In this video we have another problem involving partial fraction decomposition. The last time it dealt with a non-repeating irreducible quadratic factor. In this case we have a repeated one. So we have x to the third, and then we have the irreducible quadratic x squared plus 16. It's to the third power. Numerator is to the third degree. Denominator is to the sixth degree. So this is a proper rational expression. So we do the breakdown of this, similar to the ones we've done, except in this case, the first one we dealt with non-repeating linear factors, and then it was repeating linear factors, and then the last one was a non-repeating irreducible quadratic. This one is repeating. So here's the setup that we have for this one. We have x squared plus 16 to the third. So according to the process, then we go in the linear situation, linear factors, it was just constants on top, a, b, c, whatever. But if you have a quadratic, you expect the degree of the numerator to be one less. It could be a constant, but you're not sure until you solve for the constant. So in this case, it has to be ax plus b. It could be that the a is 0. So that's over the first factor to the first power, and then we go all the way to the third. So then we pick different constants. Now we could go a1, a2, a3, a4 if you want to say with one constant. But here we have it, then cx plus d over x squared plus 16, quantity squared. And then we go to the next one, ex plus f over x squared plus 16 to the third. Now, had this been to the fourth power, then we'd have another one. Another two constants, and then over x squared plus 16 to the fourth power. And then what we're going to do is we're going to multiply through by the LCD. So that's going to be x squared plus 16 to the third. So it's going to wipe this out. It'll divide this out. On the left side, I just leave me with x cubed. And then on this one here, it wipes out one factor of x squared plus 16. I'll have ax plus b in parentheses times x squared plus 16 squared. One of the factors divides out. And then in the next one, it says has x squared plus 16 to the second, so it cancels two of the factors. So the next one will have cx plus d in parentheses times x squared plus 16. And then of course the last one has the x squared plus 16 to the third, so that's going to divide out completely. And then I was just thinking with ex plus f. Okay, so that's the procedure that I went through to get the next step that we're going to look at. And that's this one right here. That's what I just mentioned over here. So here you can see it more clear. And then what I did in the next step, I simply multiplied out the x squared plus 16. X squared plus 16 squared is x to the fourth plus 32x squared plus, and 16 squared is 256. And then the next one we multiply cx plus d times x squared plus 16. And I get this in the parentheses. And then the last one didn't have anything to multiply that one by, so it's a cx plus f. Now, we could go ahead and complete the multiplication here on this first one, ax plus b times this expression, and do what we did earlier, especially in the first one, where we set up polynomial expression on the right side and then equate the coefficients. So if you have an x cubed on the left side, which you do, coefficient is 1. If you have an x to the fourth term on the right side, there's no x to the fourth on the left side, so the coefficient would be 0. So this is what we have then. I have ax to the fifth, rearranging terms. So I got all the terms with an x to the fifth together, all the ones with an x to the fourth together. And the ones with x cubed, those are the two terms that had x cubed, and I just factored it out. So it's 32a x cubed plus c x cubed. Just put those together. And then the ones that had x squared, there was two terms that had an x squared. So here they are, 32b plus d. Factored out the x squared. And then there was three terms that had an x. So this was 256ax plus 16cx plus ef. Factored out the x. And then everything else didn't have a variable. That's your constant. That's your constant. Okay, so here it is. All we had to do is equate coefficients. there's no x to the fifth on the left side. So that tells me a has to be 0. Okay, so that fixes that. Then I have bx to the fourth. That's the only term I have on the right side. I don't have any x to the fourth term on the left side. So that tells me the coefficient of that x to the fourth is 0, which tells me that, of course, b has to be 0. Okay, so let's look at the next one. I have 32a plus c. And it's an x cubed. There is an x cubed on the left side. It has understood to be a coefficient of 1. So I can say then that 32a plus c is equal to 1. But we know a is 0. So right away, it tells me that c is equal to 1. Okay, we got that one. So we got. And now, for the x squared, we have 32b plus d x squared. There's no x squared on the left side. That means the coefficient is 0. So that means it's 32b plus d has to equal to 0. And we know that b is already 0 from over here. So this would tell me then that d is equal to 0. And then we go to the next one. In front of x, I have a 256a plus 16c plus e. And there's no x on the left side, so that means the coefficient has to be 0. So that tells me that 256a plus 16c. And remember, c is equal to 1. Let me just put a 1 here. Place the c by 1. And then plus e. That has to equal to 0. Okay, because on the left there's no x, so that means that the coefficient is 0. And we know that a is 0. So we have 16, 1 plus e has to equal to 0. So that tells me then that e has to equal to negative 16. Now let's look at the last expression. 256. We know b is equal to 0. So this is gone. We know d is equal to 0. So this is gone. And of course this has to equal to 0 because there's no constant on the left side. So that tells me that f is equal to 0. So the only thing we can use here then is that c is equal to 1 and e is equal to negative 16. So we simply make the replacement in the original setup. Replace the c by 1 and put in the zeros for the other ones. And of course the e is negative 16. So this expansion right here then, a, b, d, and f are 0. C is equal to 1. So we make the substitutions there. And here we have the final solution. The c was 1. The e was negative 16. Everything else was 0. Thanks for watching. We'll see you next time.